New tyrannosaur bridges gap from medium to monstrous. Horse-sized dinosaur had brain, ears like its bigger relative T-Rex. In between are the horse-sized tyrannosaur Temurlengia euotica, which roamed what is now Uzbekistan 90 million years ago, already had the super senses of the giant tyrannosaurs that appeared millions of years later. A fossil from a new species of dinosaur is helping to bridge a crucial 20-million-year gap in tyrannosaur evolution. The key fossil is a 90-million-year-old, grapefruit-sized partial skull from Uzbekistan's Basekti Formation. This tyrannosaur brain case, the first well-preserved one found from the mid-Cretaceous period, shows that, although still small, tyrannosaurs of the time already had brain and ear features of later tyrannosaurs. Researchers have dubbed the in-betweener Temurlengia euotica, meaning well-eared. They describe the new species in a paper to appear in the Proceedings of the National Academy of Sciences. The brain case sheds light on a long-standing mystery: how tyrannosaurs evolved in the gap from 100 million to 80 million years ago from an average Joe horse-sized predator in the early Cretaceous to the huge apex predators they became in the late Cretaceous. Our study is the first to show that the sophisticated brain and hearing of big tyrannosaurs evolved in smaller-bodied species, long before tyrannosaurs got giant, says study co-author Stephen Bruzet, a paleontologist at the University of Edinburgh. These advantages, he adds, may have helped tyrannosaurs become such successful and eventually enormous predators. Puzzle pieces. In addition to a well-preserved brain case, researchers have found several other fragments of a T-Rex relative named Temurlengia. The size and shape of the fossils indicate the 90-million-year-old dinosaur was about as big as a horse. Analyzed against a database of other tyrannosaur skulls, the brain case shows that Temurlengia's brain and ear are almost identical to T-Rex, just smaller, Bruzet says. In particular, the dinosaur's long cochlea, a part of the inner ear, is a signature of bigger, badder late Cretaceous tyrannosaurs. The long cochlea would have meant better sensitivity to low-frequency sound, Bruzet explains. That sensitivity would have enabled Temurlengia to detect very subtle or distant sounds, giving the dinosaur clear advantages over other predators. Temurlengia fills an important gap in both time and evolution, says Lawrence Whitmer, a paleontologist at Ohio University in Athens who was not involved in the study. Charles Darwin couldn't have scripted it any better.